diri na kita mag-classify kay ako ang contours mas pogi ko tanawon gid diri gid. Mas ni ano pa siya nga na ano ang lighting no. Okay? Okay. Now, let's start. Last time we solved the Langevin equation by integrating sa katong ano no, and there we applied some theorem and found out about the, we did not guess about for the solution, right? It just came out naturally, and what we were able to solve is we were able to solve the mean, and we were able to solve the variance. Okay, and from that use some theorem in order to determine the distribution of ano, right? The distribution of the solution of x of t. And there, gi-explain na kung tarong gid sa inyo ha dito ano gid ninyo no nga it's normally distributed. But there's another way for that we don't even need to calculate for mean and variance. Meaning that it comes out naturally. Okay, there's a way to solve that you don't need to look at it as a stochastic differential equation. I mean, a stochastic, you don't need to look at t as stochastic. And you will be surprised that the solution would naturally come out as a distribution. Okay? The solution itself is when we solve the equation. Remember dito sa in our last meeting, we solved the equation. But what we were actually able to explicitly solve was the trajectory of xt, right? We solved xt. And just use some theorem to infer the distribution of xt, right? Sa katong ito, mo tong ano. There's a way to solve this, not solving xt. This is the we will now not be interested in xt, but we will be interested now. Suppose that we want to solve the distribution now of xt. Let's start with the Langevin equation. Dxt mu dt. Let's solve the Langevin equation dire. Minus ano gyud? Gamma xt dt plus sigma dwt, right? Now, consider a test function phi. Let's consider a test function phi. Phi of x, in which we want that phi of x, phi prime and phi double prime of x vanish at the boundaries. At the end, here x, okay, mura na siya at the boundaries of the kung asa defined ang function, meaning it will not diverge there. This is for the purpose of integrability. Okay? Now, what we aim is actually, we want to solve for the P of xt, the probability density function of the trajectory. In this case, we will not be solving the trajectory. We will be solving this one. Okay, last time, we solved the trajectory and used some theorems to find the distribution. Karon, kani atong ano. Okay? Now, if we expound this d phi, that would be phi prime dx plus 1/2 phi double prime dx squared, right? If we substitute this one dire, dxt, what do we get? In this part here, okay? Dito lang sa ato, we'll just take mu lang sa ano to simplify this one kay para dito magano, mu dt, the general stochastic, ano. Okay, substitute na to dire, yung sa metabo. This is now mu phi prime. This is a test function, okay? This is a test function. Okay, mu phi prime dt plus sigma phi prime dwt plus 1/2 phi double prime sigma. So you have 1/2 sigma squared dt, right? Mao ni siya dire, ang dx squared. So this is now our d phi. Now, okay, we have this phi x. What is now the expectation of phi of x? Integral over all space omega of phi of x times this one, right? P of x t dx. Okay? Over all space omega. Now, we take now the derivative of this expectation value. Phi of x phi of x. Okay, ako sa ning ano dire no? We have now d phi over dt equals mu pi prime kato plus 1/2 sigma squared phi double prime dt plus sigma phi prime d. Okay, wala na ning dt dire, right? Because we already moved this one dire. So this now becomes the plus the sigma prime times the white noise, right? Dividing it by dt. Tama? Okay. Now, of course, we know that this is constant, and this is non-stochastic. Okay? Uh, so, let's take now the expectation value of d phi over dt. Well, when we take the expectation value of this, unsay mahitabo? Zero ni siya, tama? Okay? So sa ato pa, the expectation value of this is just this, right? The deterministic part. So you have now mu phi plus 1/2 phi squared. Phi double prime. Okay? Okay. Apply this one dire sa integral. We know that ang d over dt mo apply lang sa dire, tama? Okay? And since this is a function of two variables, therefore this now becomes the integral of phi x partial p over partial t, right? Okay? Partial xt over partial t dx. Okay? The expectation value of phi Suping gamis. Okay. So, hopefully nga, klaro gyapon diri no? Um, okay. Here, and of course, our dV would be equal to pi. Asa naman ta? Pi prime. No? dx or p would be pi. Tama? So, at this integral now, this whole thing will be equal to negative of sigma partial over partial x mu p dx. Okay? UP, kani dx kaya po sa ito na combine siya, right? This is negative, okay. I-factor out na ito ang phi. Correct na ka. This is phi times the integral of minus d over dx of mu p, right? Muna siya. And then, asa na to? To? Kumbaling? UB minus BDU, right? UB, again, mag-cancel na po ng UB, right? Because we have phi that vanishes. Minus BDU. Minus BDU. So this BDU, dali dx rin, no? Sa ito pa, you have now the integral of BDU. So you will have now BDU. So you have phi. That's why akong i-factor out ang phi dito. DU. Sa ito pa here. So plus partial over partial x squared sigma squared p. Right? dx. Asa? Na ay 1/2. Okay? Tama? Now, notice that since pi is a pi function, compare this integral. In general, we have now this final form of the integral. The integral over all omega of phi partial p over partial t dx equals the integral of phi minus partial over partial x mu p plus 1/2 sigma squared p dx. Therefore, since this is a test function, this is the same limit dx. Therefore, what we conclude is partial p over partial t equals minus partial over partial x mu p plus 1/2 okay, partial over partial squared, no? X squared, so 1/2 partial squared over partial x squared of sigma squared p. This differential is known as the FOKKER-PLANCK equation. Now, let's solve now the Lec05 equation using the FOKKER-PLANCK equation. All we have to do is we have this differential equation, partial p over partial t equals, we'll ask you to do this, mag-quiz lang ta. Okay, 30 minutes. Taas-taas ang solusyon na, pero kung kabalo naman mo, this now becomes minus gamma. So may positive, right? Okay, negative gamma x man. So minus partial over partial x of xp plus 1/2 squared over dx squared of sigma squared p. This is the differential that you're going to solve. Now, how to solve this one? Apply Fourier transform. And the Fourier transform will reduce it to a ordinary differential equation in t and in k. Pag solve niyo dito sa Fourier transform, get the characteristic equations, and automatically makuha ninyo ang P hat. Okay, ibig sabihin, this one, our equation now would be in terms of partial P hat over partial T. And this equation in the Fourier transform space becomes now a P hat. In terms of actually, mulit mo no? Oh, quiz ni siya. And you will achieve the solution for P Now, in order to get back to the solution P, apply the inverse Fourier transform. That means that P of xt is equal to the inverse of the inverse Fourier transform of P of K, no? Katong dito, P of dito K, that would be SK. Okay? And you will see that pagbalik niyo dire, that is the normal distribution. You don't even need to calculate for the, and you will see automatically that what you will get is a form of normal distribution na pag i-compare mo sa standard, that would mean that x bar or the mu would be equal to x naught e to the minus gamma t, where gamma is this gamma. Okay? What? Pinahan dito sa artista diri lang ta magklase siguro ba kay ang kuno ko ng contours lagi action start kay ko tanawon ba. Yun ta magklase no. Okay, so unsa man? Quiz. Wala may battery so ano lang ni.